Assalamu alaikum. I am here to present the presentation of chemistry. Our course instructor is Dr. Atif Ali Altaf. Myself, Javeria Hanif, having roll number 5048 from section A. Today my topic is saturated, unsaturated and aromatic hydrocarbons with emphasis on the synthesis and free radical mechanism. First of all, we want to discuss with you the saturated hydrocarbons. What is saturated hydrocarbons? The hydrocarbons that contain only single bond between carbon atoms. Hydrocarbons having only single bond between the bonded atoms is called saturated hydrocarbons. They are simplest class of hydrocarbons. They are called saturated hydrocarbons because each carbon atom is bonded to as many hydrogen atom as possible. In other words, the carbon atom are saturated with hydrogen. Hydrocarbons having only single bond are called saturated hydrocarbons because each carbon atom is bonded with other many hydrogen atoms as possible. In this statement shows that the carbon atom are saturated with hydrogen. For example, the oil derived fossil fuels propane, butane and octane are some examples of saturated hydrocarbons. The oil derived which is from fossil fuels and alkanes such as propane, butane, octane, hexane, etc. All these are the examples of saturated hydrocarbons. Then properties. What is the properties of saturated hydrocarbons? Saturated hydrocarbons are not soluble in water and have low density than water. Saturated hydrocarbons are not soluble in water and they soluble in all other solvents and have low density than water means that they have maximum density. They have not maximum density as compared to water. They have less density than water. As we know that saturated hydrocarbons having single bonds, so due to that reason they have low density because hydrogen bonding with carbon atoms is low and their density will be low. Melting and boiling points increase with increasing carbon chain length or ring size. Melting and boiling point obviously increases in the saturated hydrocarbons, but due to the increase of carbon to carbon chain length, as the number of carbon atoms in the molecule increase, the chain length of carbon in a molecule increase. So due to increasing the chain length, the size of molecule will also be increased. So due to that reason, melting and boiling points of saturated hydrocarbons increases. Then we will discuss that two important reactions that saturated hydrocarbons undergoes. These two important reactions are combustion and halogenation. Then uses. What is the uses and from where sites we use the saturated hydrocarbons? Saturated hydrocarbons are all alkanes. Alkanes have only single bonds, so they are saturated hydrocarbons. Alkanes are widely used as a fuels. Alkanes are used as a fuels, heating oils and as a solvents. It is used in many solvents. A few other uses of saturated hydrocarbons are listed below. Saturated hydrocarbons are also methane. Methane is simplest form of alkane. The simplest alkane is used as a fuel in several automobiles, water heaters and ovens. Then synthesis. We will discuss the synthesis of saturated hydrocarbons. After butane, the alkane are assigned systematic names. This statement means that all the saturated hydrocarbons are alkanes, and alkanes started from methane, ethane, propane and butane and propane and so on. After butane, after first four alkanes, the systematic names were given to the alkanes. Alkanes were given to systematic names. These names shows that how many number of carbon atoms are present in a molecule. After butane, the alkanes are assigned systematic names that indicate the number of carbon atoms in the molecule. For example, carbon 5, hydrogen 12, it is a molecule and it is called pentane. It is pentane. It has 5 carbon and 12 hydrogen. The prefix penta. The word pentane means penta means 5, and it indicates that there are 5 carbon atoms, and the ending ane denotes an alkane. The word pentane in first penta mean 5, which indicate that there will be 5 carbon atoms in a molecule, and last ane, we know that all the alkanes ended at anes. So which words end at ends, we know that these molecules are all alkanes. The first 4 alkanes are gases at a room temperature. At a room temperature, first 4 alkanes, methane, ethane, propane and butane are gases at a room temperature, whereas n-pentane through n-decane are liquid at a room temperature. Then we say that the number of structural isomers increase very rapidly as the number of carbon atoms in an alkane increases. The number of structural isomers increase as the number of carbon atom in an alkane increases. This statement shows that from which way the number of carbon atom increases in an alkane, then their structural isomers also increases very rapidly. In alkane molecules in saturated hydrocarbons, the arrangement of 4 bonds about each atom is tetrahedral. As we know that carbon is a tetravalent and carbon has a 4 bonds. Carbon form 4 bonds with hydrogen. So in saturated hydrocarbons, alkane molecules, the arrangement shows which is tetrahedral. And all the hydrogen to carbon bond, all the hydrogen to hydrogen carbon bond, and all the carbon to carbon bond angles in these molecules are close to the ideal tetrahedral bond angles, which is exact 109.5. This statement whole as a whole shows that carbon is a tetravalent and carbon form 4 bonds with hydrogen, and all of these bonds are tetrahedral bond angles, which is 109.5. Then unsaturated hydrocarbons. What is unsaturated hydrocarbons? Unsaturated hydrocarbons are the hydrocarbons having double or triple covalent bond between adjacent carbon atom. Unsaturated hydrocarbons contains double bond and triple bond with other hydrogen atoms, with other adjacent carbon atoms, and it does not have single bond because single bond contain only saturated hydrocarbons. But unsaturated hydrocarbons have double bond or triple bond, which is present in alkenes and alkynes. The configuration of an unsaturated carbon includes straight chain such as alkanes and alkynes, as well as branch chains and aromatic compounds. Unsaturated hydrocarbon compounds. Unsaturated hydrocarbons is more reactive. Unsaturated hydrocarbons is more reactive. They have pi bond and they are weaker. As we know that unsaturated hydrocarbons is more reactive as compared to saturated hydrocarbons, because saturated hydrocarbons have only single bond and they have minimum ability, but unsaturated hydrocarbons have double bond or triple bond and they are more reactive. They have pi bonds and they are weaker. As we know that saturated hydrocarbons have sigma bond, and sigma bond is more stable and more stronger than the pi bond. So in unsaturated hydrocarbons, pi bond is present, so unsaturated hydrocarbons are weaker as compared to saturated hydrocarbons. Then example of unsaturated hydrocarbons: alkenes, alkynes and aromatic hydrocarbons are unsaturated hydrocarbons. Alkenes and alkynes, due to the presence of double or triple bonds, they are unsaturated hydrocarbons, and these are the suitable examples such as aromatic hydrocarbons for the unsaturated hydrocarbons. Then we will discuss the structures of saturated and unsaturated hydrocarbons. In saturated hydrocarbon, only single bond are present, and in unsaturated hydrocarbons, double bond and triple bond are present. So these structures were given below in the given diagram. You will see. Then what is aromatic hydrocarbons? What is aromatic hydrocarbons? Aromatic hydrocarbons are a special class of unsaturated hydrocarbons. We know that aromatic hydrocarbons are a unsaturated hydrocarbon, and it contains 6 carbon ring moiety. Moiety means molecule, and it contains 6 carbon ring molecule, which is called benzene. So we can say that aromatic hydrocarbons are actually a form of unsaturated hydrocarbons having 6 molecule, which simply called benzene. This saturated hydrocarbon, which is cyclohexane, it is actually a saturated hydrocarbon, but when we add 3 alternating double bonds, then it transferred into aromatic hydrocarbon, aromatic compound. When cyclohexane having saturated hydrocarbon is added by 3 alternating double bond, then it is transferred into aromatic hydrocarbon, which is called benzene. For example, aromatic compounds are benzene, naphthalene, and anthracene, etc. Then synthesis of aromatic hydrocarbons. The synthesis of aromatic hydrocarbons from carbon monoxide and hydrogen. We say here that aromatic hydrocarbons are produced or synthesized by carbon monoxide and hydrogen, which was studied under the pressurized condition using hybrid catalyst composed of methanol synthesis catalyst and zeolite. The synthesis of aromatic hydrocarbon was studied under pressurized condition, which were a hybrid catalyst having methanol synthesis catalyst and zeolite. Then we will discuss that how the conversion of synthesis gas to aromatic hydrocarbons. The conversion of synthesis gas to aromatic hydrocarbons over a new class of catalyst comprising a carbon monoxide reduction function combined with the ZSM5 class zeolite is reported. It means that when synthesis gas is converted into aromatic hydrocarbon, then a new class of catalyst is formed, which have carbon monoxide reduction function combined with the ZSM5 class zeolite, which is reported, and the polystep nature of catalyst is analyzed. Then we will discuss that simple aromatic hydrocarbons come from two main sources. One is coal and second is petroleum. Coal is complex mixture of large number of compounds. As we know that coal is a complex mixture of large number of compounds. Most of these large compounds are long chain compounds. If coal is heated at 100 degree centigrade in the absence of air, then the resulting compound is volatile component, so the so-called tar oil are stripped out. It means that when we heated the coal at 100 degree centigrade in the absence of air, we know that in the presence of air, then every type of combustion process regulates good, but in absence of air, the volatile components are formed, and these volatile components are called tar oil, which are stripped out due to the absence of air, and these forms a stripped layered procedure. So now our synthesis of aromatic hydrocarbon is completed, and thank you so much. Allah Hafiz.